We will jump into the iOS application anatomy in this section. So the architecture of iOS is layered. It means that the iOS intermediates between the underlying hardware and the application you've built through a set of frameworks. A framework is nothing but just a directory of shared library files or dynamic shared files with .a extension. We will shed more light on that topic as we progress in this course. Now, the layers you see here on the screen all reside on top of the main kernel and drivers layer. So the iOS components that support iOS applications together with the application layer make up the architecture of an iOS application. So let us detail what do these layers actually do. The application, or you can name it the Cocoa Touch, is responsible for the user interface and views control, mainly nothing more than touch and motion events and user interface management, such as, for example, copy and paste. Now, the media layer is responsible for the graphics, audio, and video set of technologies. The core services is mainly responsible for security. The core OS layer is a low-level feature layer that is mainly responsible for the accelerate frameworks in addition to some Bluetooth technology. So let's go into more details on that slide. As you can see here, the kernel and drivers has mainly the BSD, the file system, the MAC, which is the data structure or file system of the iOS. On top of that, you have the core OS services, image, audio, animation, core services such as the address book, quick look, core foundation, the media layer, as we discussed now, audio, video, animations, and on top of that, the applications layer or the Cocoa Touch. We have three main types of iOS applications: the native, the hybrid, and the web-based. Native applications are developed using Objective-C or Swift language under the Xcode IDE. The hybrid applications use frameworks such as PhoneGap, Cordova, the React JS frameworks to build such applications. They can as well be integrated, or they can use some Objective-C or Swift language. The web-based are responsive versions of websites built for working on mobile devices. In this course, we will be mainly focusing on the native iOS applications built with Objective-C and Swift language. Let us go into more details on the structure of the iOS application on your device. So during the installation, the installer creates certain directories on your device. You will have mainly the bundle directory and the data directory. There are two main paths for that: var containers bundle applications, and then the UID for the bundle, and then the var mobile containers data and UID. Keep in mind that the UID for the bundle and the data is different. So the purpose of the bundle actually is to prevent tampering of data outside the sandbox. So because the application and generally prohibit accessing files outside this sandbox. So the application will actually access all the data within its bundle and the data location. Now, within the application data directory, the iOS generates a number of special purpose directories intended for particular types of data, such as documents, library, and temp, as you can see here on the screen. The documents directory is mainly used for user-generated content. The library directory is used for storing files that are not user generated and data. The temp file, as the name specifies, is temp data that might be purged later on. We also have application support under the library, which has some hidden support files. We have the cache data, and we have preference directory that will store preference data. Some of these directories are backed up by default, and some of them are not, such as the temp directory and the cache directory. Now, moving further, it's really important to discuss the file encryption methodology in iOS. iOS provides per file encryption through the Data Protection API. We have 4 levels of protection, the lowest being none, and the highest is the complete set of encryption. Now, the lowest one is NS file protection to none. It means that the keys are always available for the application. The second one is the NS file protection complete until first user authentication. It means that once the device is booted and unlocked, the keys remain available until the device is rebooted again. The third type of encryption is the NS file protection complete unless open. It means that the keys are briefly available when the device is locked, and the keys are accessible when the device is totally unlocked. The fourth and the strongest type of encryption is the NS file protection complete. It means that the keys are inaccessible when the device is locked, and all of this actually depends on the fact that a user is setting a strong passcode on the device, because the encryption mainly depends on the passcode that is being set by the user. Going forward in this course, we will see how to view the attributes of each file in our application using the XATT command. Keep in mind that the default level of encryption provided by iOS is the second one, the NS file protection complete until first user authentication. The 2 lowest classes have some shortcomings in where the data at rest can be decrypted when the device is locked, due to the fact that a computer or the device can trust a computer, and the user will be able to access these files and decrypt them. Now let's move on explaining some methods used by iOS to store information. We have three methods. The first one is the NS user defaults. Actually, this is used to store preference files, key values, etc. The main file used is the info.plist file, which resides under library preferences, then the bundle ID. Actually, this file is a manifest of the iOS application. It contains information about supported devices, bundle ID, the display name, application, transport security. It can store data in the format of integer, float. It will also have simple key values and primitive data types. It's not that well encrypted, and it's not suitable for storing information such as passwords. The second storage type is the core data, which actually stores this set of complex but structured data storage. It uses the database SQLite, which is the common format for databases used on mobile devices. It's a self-contained file which is portable. Usually in other platforms it can have the extension of DB, but it is .SQLite on the iOS devices. SQLite as well uses another file called write ahead log, or the WAL file, which is a separate file actually to store the changes before being executed on the database. This file can have important information such as usernames and passwords. Last but not least is the NSKeyed Archiver API, which is used to store complex types of data that needs to be serialized. It can have the extension of a plist, or it can have the format of a plist but without the plist extension. The values in these files, the values in such files can be encoded in base 64 format. Other types of file that we will discover in this course are the binary cookies, in which the app maintains to store the cookies, especially for the NSURL session ID. As well as the cache.db, which is the on-disk cache file used for NSURL requests and responses. Now let us explore the IPA structure of a mobile app I have here on my laptop. I will open this unzipped folder here and go to the payload. And then you will see this DVIA version 2 application, which is the damn vulnerable application, which is an iOS application, which is actually a vulnerable app. Now, how to explore this? I'll just right click here and show package content. As you can see, there are lots of important files that depict the structure of an iOS application. You can as well do the same by using the terminal here. So let me close this. I will just navigate to the terminal, go to my desktop, use the autocomplete feature. Here, if you list, you'll see that there's a payload, and if you navigate to the payload, you will see the damn vulnerable application. Let me dive deeper into that and list the content, and here you go. You will see the content of the application as we have just explained. This can be viewed in a color code on the Unix environment, in where you will see different set of folders and files explained. I will just here explain some important directories that we will be working with throughout this course. The meta.inf directory contains two files which hold the metadata about the IPA file. The app directory, this is the directory actually that holds all the component of an IPA file. You will also see some subdirectories for localized resources. These are the language-specific project directories. They can be with an extension of en.lproj or fr.lproj. This helps in switching the languages of the application from the available languages as desired by the user of the application. You will have as well the code signature directory. This directory contains the file code resources, which is used to store the signature of all the files in the bundle that are signed. The frameworks directory holds the information about the frameworks that an application uses, and the scinfo directory contains keys which are used for decrypting the application executables. The files in this directory help in integrity checks of the application. The info.plist file is an important file, as we have just mentioned. It's the manifest of the iOS application, and the package.info file is an alternate way to specify the type and creator codes of the application or bundle. This file is not required actually, but and sometimes used to improve the performance of the code that accesses this information.